Okay. Now, as much as this pains me to say, it says use row operations to solve it. Do you have to use row operations to solve it?
No.
No, but let's take a crack at this and see what we can do with it, okay? So I'm going to go ahead and copy this over.
I like that. Sure, what I did was a row operation.
Okay, go ahead.
I put a 1, -1, 0, and in that case, yeah.
No, that should be 0, right? 0, 1, 0, 1, -1?
Yep.
2. So it should be 1, 0, 1, 4. Well, half of it's already done.
Yep.
All I need to do is to get this bottom one to be a 0. The way I'm going to do that is I'm going to take row 1, multiply it by -1, and add it to row 3. Right? So the values, after multiplying the first row by -1, it's going to be a -1, 1, 0, -4. Now I'm going to add them to the last row here. So that should give me, I'm going to just do it in red right under. Is that cool? So I should get 0, 1, 1, 0. Is that correct?
Yeah. Hold on.
So what? Now what do we add?
What?
Like you make your own rolls and everything you go. Cause how do you get +3?
No, I'm taking row 1. Oh, sorry. I'm adding it to row 3. Thank you.
You can multiply.
Good observation.
So, right, only divide.
Okay? You can multiply.
Wait, where did you get all those numbers from?
I took row 1, right? Row 1. I multiplied it by -1
No, I'm saying that. Where did you get those?
from here.
In the. Yeah, but there's only
Tomorrow
3
is really when it
in
starts.
each row. How did you get 4? Oh, okay, wait, never mind, I got it.
And we can't take it. We
Right?
cannot go to
Because,
The coefficient of x is 1, right? On the first row? Coefficient of y
It goes X, Y, Z, and
Correct.
then whatever there's
it goes to get a 0. Okay? So, here's what I've got. I'm going to clean this up. I've got
I'll just talk to him.
1, -1, 0, 4, 0, 1, -1, 2, 0, 1, 1, 0. Yeah?
I already told him that I wasn't going to make this controversial. Why? I said because I-
More?
He said that's one of the reasons this passed.
I'm gonna check.
Does that say -1 R?
Right now, because my 34,000 split, our 34,000 split.
Are we
So
good
you
here?
added the row 1, well, you multiplied it to a -1, and then added it to the third row.
Right, I added them to the third row. Are we good here?
Yeah.
Okay. I need this one to be a 0. How? Take row 2, multiply it by -1, and then add those numbers to row 3. So row 2, -1 times 0 is 0. -1 times 1 is -1. -1 times -1 is a +1. -1 times 2 is a -2. Right?
Yeah.
Okay. Okay. So 1, -1, 0, 4. 0, 1, -1, 2. You got it. Okay, let's add them up. Got 0, 0, 2, -2. Correct, Mundo?
You have to make it a 1.
Make what a 1?
The 2.
I have 2 0.
I could finish it, but I already know that y equals -1
Are you gonna?
Oh, that's true.
because 2y equals -2, which means y should be -1, right? Take that, plug it in here. So this one says y minus 1z z is equal to 2. That's a -1. Add 1 to both sides. So -z is equal to 3. So z is equal to -3. Take those two answers, plug them up here into the last one, and get your x value out. Man, I'm cansado.
Did you get the y from the second
You
number?
alright, Munoz?
Hey, no, it's Stephen's board.
Yeah.
Are our annotations for homework?
Document.
Okay?
She said started.
Done? Hello?
Yes.
No other questions? I'm going to take that as a no. Alright, close your laptops, get some paper for some notes. Because it's time. 4. Don't do that. Ugh. So contagious.
You alright, Munoz?
No tutoring today. Maybe.
Hey, I was
Yeah.
playing with that.
Yay. Here we go. Silencio. Chase. Okay. Chapter 4, section 4. We're doing more matrices. So we're keeping that spirit. So we're going to do some properties of matrices. We're going to start off with some basic definitions of matrices. We're going to add subtract matrices. We're going to do some scalar multiplication. And then we're going to multiply matrices.
What time do we get out?
When the bell rings.
1:40.
What's the date?
Okay?
Already. 4, 5.
Wow, I can't shake it. Can't shake it off.
That's a sign.
Here's your time. Okay, are we good? All right, let's start with knowing the basic definitions. We've already talked a little bit about what? Yeah, calm down.
Statistics.
Stop crying. Stop crying.
I didn't do anything.
Oh, I wasn't looking at you.
Oh, it looked like you were looking at me. I'm like,
No, it's not all about you.
Happy birthday.
Conceited.
Don't see.
Wow.
This slide, all I'm telling you with this slide is that every matrix, we always label it with a capital letter. So in this case, we're talking about matrix A. Matrix B would use a capital B. If I had a different one matrix called matrix C, it should be a capital C. All the elements inside are lowercase, and those numbers that you see there are not truly 11, 12, 13, 14, whatever it is that you're looking at. Okay? That's an address, and it's for the subscript. So, for example, if we're looking at this first one, this is called A sub 1, 1. Because that's telling me that it's row 1, column 1. Okay? So when we're talking about this guy here, that's not A sub 23, that is A sub 2, 3. Meaning second row, 1, 2, third column. So I know how to get to that bad boy. Okay, so not A sub 23, A sub 2, 3, so forth, so forth, so forth. So this would be A sub 1, 1, A sub 1, 2, A sub 1, 3, and it goes on forever, A sub 1, whatever. Okay? That's all you need to get out of this slide. Questions on this slide?
No.
No, but I'm
Do you have to use lowercase numbers as well?
Yes, you have to use lowercase numbers as well. That was good.
I was waiting for an opportunity to say it.
Now you got it. That's how we're going. All right, cool. Moving on.
So that means
Nice. Column 1, 2, 3.
Oh, sorry, you can't hear me now in my head. Yes. What's up, Shane O'Mac? How you doing? Shane O'Mac. Those are ellipsis points. That means it goes on forever in that way.
What are the
yeah, it
ends?
was a shooting
The
star.
ends.
And the pattern continues.
Are the ends just signifying that it's infinite? The end?
Oh my
It's just a letter.
Why
Yeah.
is this?
It's whichever last value goes there.
I think the reason why
Last
it's
row.
slower on the phone is because it's like
Moving on.
closing.
I can tell you guys are done when you guys start talking a lot. Of course, we talked about some of the matrices having special names. Yesterday, we talked about the square matrix. And the square matrix, it talks about a matrix that has the same number of rows as it does the same number of columns. So if it has 3 rows, 3 columns, that's a square matrix. It's called a 3 by 3. If it has 2 rows, 2 columns, that's a 2 by 2. But there are other 2 scenarios. For example, if a matrix has only 1 row, we call it a row matrix. And if it only has 1 column, can we call it a column matrix? Okay? And if you have matrix A equal to matrix A, then those 2 matrices are equal. Okay? So if one matrix has the same value as the other one, we call them equal. Which I think you guys should already know, right? It's like not new math here.
If it's not, then it's
Not equal.
and it's no
Wait.
solution.
I've waited.
Waited. If it's not, then it's no solution.
That is no. That is no.
Is that your favorite word? No.
Yeah, it's my new favorite word. Once I came in this class, that's my new favorite word.
I thought it would be echelon.
Is there an upper echelon?
We're not military, bro.
What is echelon?
Yeah, right.
Can't do that to me, man.
I've been staring at it. It's like
Inception.
There's a blue heart in line that should be in that.
when you
I think you
when
should
you shake
flip
it
it
up
over.
and then it's like all really bad and you look at it, you're like.
You know what it looks like? It looks like you put some magic sand inside a case.
Are you good, Blackwater?
Magic sand. This is
Magic.
what people should hide cocaine.
No.
Do you get magic sand on Magic Beach? On the Magic Island? Or Magic
Can we go there?
Yeah, I dusted it off my magic carpet.
Yeah. You don't see into the quarter.
Alright, Mr. Next slide.
Fuck.
I bought it from MC Magic. And regular men, yes it is me.
And you were just like,
that iced tea, that guy from the commercial.
Okay, here's an example. If these truly are equal, notice the two square matrices are supposed to be equal matrices. That means that the value of x is, value of y is. This is so difficult. P is, Q is. What is x?
1. Wait.
No, 2.
4.
Wait, no, it's 1, 4, and 0.
Obviously they're not equal. Even though they're both column matrix, one has 2 elements, the other has 3 elements. So no, these cannot be equal. You need to be able to call shenanigans at this point. So this statement can never be true.
So
Even though
the
they
top
told
one
us it
is
was.
equal
Can,
Gabby, I love you.
because it's the 4th and then that one's not.
oh, it has no solution.
No solution. Because it's like no.
It just nulls up.
that was really bad.
All right, let's do some hard stuff here. You guys are ready?
Go.
We are going to add and subtract
Oh no.
Subtract.
some matrices. All right, it's not that difficult. I'm just going to follow this example. I don't know why they didn't do the whole.
They make it seem difficult.
Look, what is 5 plus a negative 4? There it is.
What is 6?
What is 8 plus 8? There it is. What is 9 plus a negative 3? There it is.
What is
Slow down. Yeah, because they want to explain, but sometimes it's just overwhelming. Like you said too much. Negative 6 plus 6? 0. Now the only time I do have to caution you is be careful when you do subtract them, because remember, even with like negatives, you have to distribute that, don't you? So that just means it's changing all these values. So if I have 8 minus 3, there it is. 6 minus 5, there it is. Negative 4 minus a negative 8. Excuse me. Obviously it's a positive 4 because negative would make a positive, and then so nothing strange there, yeah?
I want my cappuccino.
Yeah, let me clear up some of this ink.
Well, it kind of have to be vertical though,
it's not E.
to like move them around. Or like you had like
Okay.
put a magnet inside and then a magnet on top.
Any questions here? So
We're inventors.
$1 million idea.
In the sky above the mountains.
All above, all outside.
I want to
I
be
guess
like
like
that.
back then, like I could do a
I
mountain.
don't have an idea. I have a made in China. But it's still. But the thing is,
I don't know how you get more glitter coming in. There's like little more. Where's the coat?
Right there.
So judgmental.
okay. Okay. Multiplying a matrix by a scalar. A scalar. Is ready? No?
Is it the same thing but you?
Same but different.
It's exact the same but different. Okay. They're going to say all of this jargon. Too much jargon for me. I'm not going to do this exact example. I'm going to actually just get rid of that 4 for you guys. And we're going to, just so you can see the idea behind it. And then we'll do it with the 4, okay? So let's call 3 the scalar here. And yes, it really is, just multiply it out. 3 times 20,
60.
3 times 12,
36.
3 times 36,
So that's 8. Carry the 1.
3 times 16. You're done. Scalar multiplication.
60,
It is a scalar. Now, any questions on that at that point?
No.
Ah, yay!
Can you go back?
control.
It didn't do it.
Oh my god.
It didn't do
Oh,
it.
it's probably undo from my brother before.
Not nice with
Yeah. Or the negative order matters the most.
Where's it at?
Right there. Oh, there's the 4. Nice. Okay, there you go.
Why didn't you do both of them?
It's not erasing either.
Hey, you're too short.
You messed up, Munoz.
That really messed up.
Because I did it with the mouse.
Now I don't even want to like touch it.
You want to keep your ink?
Okay, so what do you do with 4? The same thing?
No. Because this is 3/4, that means that the whole matrix is going to get smaller.
Divide.
So we're making the whole matrix smaller. So 3/4 of 20 is 15. 3/4 of 12 is 9. 3/4 of 36 is not 12. 27. 27. And 3/4 of 16 would be -12. So there you go. If you're wondering how I did that, I just said 20 divided by 4 is 5. 5 times 3 is 15. 36 divided by 4 is 9. 9 times 3 is 27. 12 divided by 4 is 4. Sorry, just kidding. 12 divided by 4 is 3. 3 times 3 is 9. -16 divided by 4 is -4. Times 3 gives me -12. So that's scalar multiplication. Is that easy?
That
Okay?
doesn't do it way to be done.
Yeah. If you're multiplying by a fraction,
Yeah.
yeah.
Is that the best one?
That's the way it goes.
Divide the bottom and multiply the end for the top one. Here, wait.
Why aren't you looking to get splat? Avery? Nothing.
I feel bad for you. Don't you have like 2 meetings after this?
One. How long meeting? That I know.
One very long.
That I know. Moving on.
It's about the clouds.
Alright, here's where it gets good. Thank you. Objective 4 is to multiply matrices. And they're going to give us a bunch of mumbo jumbo. I'm going to just go ahead and tell you how it's done. When you multiply matrices, you're going to want to look at their dimensions. And their dimensions are done in row by columns. So, let's say the first matrix, let's say matrix A, its dimensions were 2 by 3. And the other matrix was a 3 by 3. Okay, so we'll say this is matrix A, this is matrix B. The question is, can I multiply the two? Okay? Now, they're not the same, right? So can you multiply them? Yes, you can. This is what you need to take a look at. Take a look, always put them side by side, and look at the two inside ones. If the two inside match, then you're going to get an answer matrix that is the dimensions of the two outside numbers. So in this case, my answer matrix would be a 2 by 3.
Wait, I thought it would be a 2 by 3.
Nope, it's a 2 by 3. Okay? So please make sure you understand that. Put the two matrices dimensions side by side like I did. Check the inside and see if you can do it.
Doing that.
I did too.
I've been so.
There's a 2 right there.
So you do want to
Why
put
didn't
in
you get
order
3
of
from the right side?
letter A and letter B then?
In the order in which you're going to multiply them.
Yeah.
So here's what I mean. Take a look. Let's say matrix A is a 1 by 3, and matrix B is a 3 by 2. Okay? Now, if I said I want you to find the product of A times B, well, that's 1 by 3 and 3 by 2, correct?
Yeah.
The two inside match. So what's my answer matrix going to be? A 1 by 2. Now, if I ask you to find the product of B times the product of A, is that doable? Well, we just did A times B, right? So can I do B times
But
A?
it's 2 times 1.
The answer is no, because I have a 3 by 2 with a 1 by 3. Do the insides match? So it can't be done. CBD. Please know that rule. Save yourself some time.
Wait, CBD is a rule?
What's up?
Cannot be
Could
done.
you,
No.
could you re-explain the whole, inside thing and then what the actual dimension is?
Well, we'll do some examples, and you'll pick it up because it's not that difficult of an idea. Oh, now I want to erase. So let's go back to this real quick, okay?
So this is a totally different problem.
No, I'm explaining the whole idea of the inside. So they're asking me to multiply matrix A by matrix B, and yes, that means multiply, right? No symbol between them. What are the dimensions of A?
The 1.
1 times
It's a 1 by 3. And what are the dimensions of the B?
3 by 2.
3 by 2. When I'm looking at it this way, I want to make sure that these two match. If they match, I can do the multiplication. The answer matrix would have one row with 2 elements in it. We'll call them A, 1, 1, and, A, 1, 2. That's it.
Oh, so whatever is outside of the.
Are the dimensions of the answer matrix. Okay?
So then it's 1 by 2.
Correct. Alright? Let's do it.
When we're multiplying them together, it's just basically that if they're the same in the middle, then they're the opposites.
Yes, if the middles are the same, if the 2 on the inside are the same, then you're going to get dimensions of the 2 outside. Let's do
They don't
this.
match, no.
That's stupid.
Whoa, that's such a strong word.
It was a stupid shortcut. Not even just.
Okay. I've got a 2 by 3 and a 3 by 2. Is that multipliable? What's my answer matrix going to look like? It's going to be 2 by 2. So, how do you do this? You guys ready?
It's a 2 by 3 and a 3 by 2.
Wait, what is this supposed to be? 4 by 2?
It's different, but yes. It's not like the scalar one, okay? So please be patient there. So let's start with the first one. Is that cool with everybody? I want this element, which is row 1, column 1, correct?
Yes.
To get that, you need to take row 1 and multiply the values by column 1.
Oh, I see.
So would it be?
So.
Would it be 18?
And it's going to go like this. This times this, plus this times this, plus this times this. So, -3 times a -6,
It's 18.
18, plus
8.
4 times 2,
8,
plus,
6,
what is that?
32.
32? 32 goes right here.
Yeah, Berto is smart.
Questions there? Simple enough? Now what's
Wait, then how is it gonna be a 2 by 2 though? Because if you multiply the next row by the next column, then you're only gonna have.
hold on. Okay, so what do you want to do now? What do you want to find? Which element do you want to find from the answer matrix? I'll use another color. Row 1, column 2?
Yeah.
So row 1, you want this one? Okay, so row 1, column 2.
Oh, I see.
Ready? That is a negative 12
12,
plus
12,
12 plus
or negative
12 minus 12 is,
0,
so I get,
or negative.
there it is.
That's simple.
Good.
When I get home,
This is multiply matrices. So a matrix times a matrix.
Multiplying numbers, but in the squares.
That makes it all blurry. Aw, man, I didn't try that.
So what column is row 2? It's
Let's find this one. Let's find A sub 2, 2, 2. A sub 2, 2. Find A sub 2, 2 for the answer matrix.
I did it. Can I go before?
that's a good sound.
Yeah, looks like they can just look at it.
How was that?
Wait, so
I did it to Craig earlier and he freaked out. It was awesome.
Freaked out over a piece of paper?
No,
Well, she didn't
It's
put
over
it.
there
She didn't put it in the
underneath
it's
board.
under the cord.
Oh, does that mean 3 push-ups?
That wasn't
I
your
threw it.
trash.
It wasn't towards the trash can. It was towards you.
Hey, I'm
didn't
trash.
get in the
You're not a kid though.
Just
You're
kidding.
not a kid though.
Yeah.
You're not a kid.
Me llamo Raquel, algo así, ¿no?
I don't know. I just listen to the music. I just hear the music. I don't listen to it. Sorry. So that means we would have gotten 20 plus 0 plus a negative 8, which is 12. And for the last one, it should have been
So it's 2, column 2?
it should have been
Where did you get the 20?
second row. Huh?
Where did you get the green
Oh. It was because that's the second row, second column. Second row times the second column. So 5 times 4 is 20. 0 times 3 is 0. 4 times negative 2 is negative 8.
So
Math.
the 32, Mr. Munoz, it's row 1, column 1.
Correct.
And then for the negative 4, it's row 1, column 2.
Correct.
And then that bottom row is row 2, column 1.
So which one's
And then
missing?
the other one will be row 2, column 1.
Correct.
It's a fine clip.
Homework